Hi all, welcome to Anil Nair classes. You are on Anil Nair classes YouTube channel. We were discussing simplification. Topic simplification session number 1. I just discussed. In case if any of the student who has missed out watching simplification session 1, kindly watch it. Simplification session 1. We just discussed the concepts but not the problems. In session number 2, I will discuss more of application of the concepts. In simplification session 1, we discussed how to find the unit digit of a number. How to find the unit digit of a number. Then we also discussed how to find the last two digits of a number. In last two digits, what are the concepts that we discussed? X square 50 into k plus or minus x whole square. K is a natural number. It will have last two digits. X square 50 plus x whole square 50 minus x whole square. 100 plus x whole square 100 minus x whole square. All will have same last two digits. Similarly, we discussed if I cube a number x cube 50 into 50 plus x whole cube will have the same last two digits only if x is even. These also we have seen the concept. I hope it is clear. 14 cube and 54 cube. It will have the same last two digits on cubing. How many three digit numbers? Suppose for example, if the question is like this. If the question is like this. How many three digit numbers? How many three digit numbers on cubing? How many three digit numbers on cubing ends with 28? Listen carefully, sir. One example. How many three digit numbers on cubing ends with 28? Now see here. First we have to find out the smallest number. There is a natural number. On cube it is ending with 28. Once we find out x, then on cubing we know the logic that x cube 50 plus x whole cube, last two digits will be same. X cube 50 plus x whole cube, last two digits will be same. Now if I use these concept, x cube is ending with 8, that means x will be 2 cube it is 8, not possible. Next number is 12 cube. If I use a plus b whole cube, 12 cube is 1728. Yes, we got the value of x as 12. So 12 cube and 50 plus x, 50 plus 12, 62 cube. This will be having the same last two digits, but I want a three digit number. So hundreds place, it can be from 1 to 9. Hundreds place, it can be from 1 to 9, ending with 62 cube. It can be 112 cube, it can be 162 cube, 212 cube, 262 cube. Here 9 numbers, here 9 numbers. So 9 plus 9, total 18 three digit numbers are there. On cubing it will end with 28. This is how you can solve most of the problems through understanding of the concept, that too very fast. If you do not know this concept, x cube 50 plus x whole cube, last two digits same, then probably you will think that this question is difficult. I hope the idea it is clear. In case if you are enjoying all the shortcut videos and you are a new user, I welcome you to Anil Nair Classes YouTube channel. Kindly subscribe to Anil Nair Classes YouTube channel. You can also like our Facebook page, that is Anil Nair Classes. Through these classes, I wish to make every student extremely competent, extremely fast, extremely high on getting the marks through my 15 years of experiential shortcut. This is what we discussed. Then we also discussed the concepts based on perfect square digital sum and perfect cube digital sum. Perfect cube digital sum. Now see here. Let us discuss one more concepts. First we will complete the concept, then we will discuss. What is the concept that we discussed? Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. 1, 4, 7 or 9. Example. if he gives a question 1 2 double 3 2 1, 1 2 double 3 2 1, now you will be confused whether you should find the square root of a perfect square or the square root of a non-perfect square. Let us use the digital sum. These nothing but 3. So a perfect square always has a digital sum 1 4 7 or 9. So which logic we need to use here? We need to use square root of a non-perfect square. We need to use the concept of a square root of a non-perfect square. I hope it is clear. Suppose if it is root of cubed root of 123. What is the another concept that we discussed? Every perfect cube has a digital sum 1 8 or 9. This also helps us in finding out, right, whether it is a perfect cube or not. 1 plus 2 3, 3 plus 3 6. Every perfect cube has a digital sum 1 8 or 9, but the digital sum of 123 is 6. Now which logic we need to use? We need to use the logic of a square root of a non-perfect cube. So just by looking at a question, there is no confusion. If it is digital sum is 1 4 7 or 9, it is a perfect square. Use the concept of square root of a perfect square. If the digital sum of a perfect cube it is 1 8 or 9, then use the concept of square root of a perfect cube. Otherwise we will discuss the concept of square root of non-perfect cube. Now write down in session number 2, simplification session 2. Simplification session 2. Let us discuss concept by concept first. Simplification session 2. Concept number 1. How to find the square root of a. How to find the square root of a. First concept. It is perfect square. How to find the square root of a perfect square? Now see here. For example, it is square root of 2916. It is there. Step number 1. Start from the rightmost. Keep a slash after 2 digits. After 2 digits. One more example we will do. Square root of 5329. Square root of 10816. 10816. Here also put a straight line after 2 digits. Put a straight line after 2 digits. These ending with 6. Already we discussed a number on square ending with 6. It has to be 4. 4 or its tens complement. 6 square is 36. 29 lies between which two perfect squares? 5 square is 25. 6 square is 36. Take the smallest value. Answer is either 54 or 56. Answer is either 54 or 56. Now use the concept of digital sum. Whichever digital sum it is matching, that itself is the answer. Square root of 2916, if it is equivalent to 54, 2916 equivalent to 54 whole square. 9 deleted. 2 plus 1 plus 6, it is 9. 54, it is 9. 9 square is 81. Again 9. 9 equivalent to 9. There are two options that are possible. The option where the digital sum is matching, that answer is the right digital sum. I hope the idea it is clear. Again square root of 5329. It is ending with 9. What is the smallest natural number? On square it will end with 9. 3 square 9 or 7 square 49. 3 or 7. 53 lies between 7 square 49. 8 square 64. Take the smallest value. 73 or 77. Check it out where the digital sum is matching. Root of 5329 equivalent to 73. So if I square it on both the sides, 5329 equivalent to 73 square. 9 I can delete it. 5 plus 3 8, 8 plus 2 10, 10 it is 1, 1 equivalent to 1. Digital sum is matching for 73. Or you can take 75 square. 75 square is 5625. 5300 is less than 5600. So answer is 73. Again it is ending with 6. It is 4. Tens complement of 4. It is 6. 108 lies between which two squares? 10 square 100 and 11 square 121. So it is 104 or 106. The digital sum will match for the first one. So answer is 104. I hope the idea it is clear. Square root of a perfect square. Every perfect square digital sum should be 1, 4, 7 or 9. 6. These also 6 plus 2 plus 1 9, 9 plus 9 18, it is 9. Again it is 8 plus 2 10, 10 plus 9 19, it is 1. Again it is 7. Every perfect square digital sum should be 1, 4, 7 or 9. One more example, then we will solve. D. Square root of 7744. Step number 1. Start from the rightmost, keep a slash after two digits. 2 square 4 or 8 square 64. 8 square 64, 9 square 81. So it is 82 or 88. Check with the answer option where the digital sum is matching. Root of 7744 is 82. If I square it on both the sides, 7744 equivalent to 82 square. Check if it is matching. 14 18. 4 equivalent to 8 plus 2 10. 10 digital sum is 1. 1 square equivalent to 1. 4 equivalent to 1. Digital sum is not matching. So answer is nothing but 88. I hope the idea is crystal clear to you. How to find the square root of a perfect square? A perfect square digital sum will always be 1, 4, 7 or 9. Suppose if the question is square root of 23. 23 digital sum is 5. It is a non-perfect square. Root of 62. 62 digital sum is 8. Right? It cannot be a perfect square. So the next concept is how to find the concept 2. How to find the approximate value. How to find the approximate value of a non-perfect square. How to find the approximate value of a non-perfect square. Now, the first thing what you require is f of x is x square. F dash x change is nothing but 2x. Please put a star mark on this. Right? I will come back to it. What is that? Suppose if it is root 13. Step number 1. Root 13 is just greater than root 9. So it is answer is just greater than 3. 3 plus 13 and 9. What is the difference? 4. Double this value. 2 3s are 6. So answer is nothing but very close to 3 2 by 3. Answer is nothing but very close to 3 2 by 3. Suppose if the question is root of 61. Root of 61. Either you can take the perfect square just less than root 61 or the perfect square just greater than 64. Root 64, 8. Answer is less than 64. 8 minus 3 by double this value. These nothing but f dash x is 2x. These Ramanujam's way of solving. 8 minus 3 by 16. Sir, can I take root 49? Which is 7. 7 plus 61 49, which is nothing but 12. These double, these 12 by 14. These 2 6 are 12, 2 7s are 14. Answer is 7 6 by 7. Answer is 7 6 by 7. Here it is 3.6. 36 whole square is 1296. 3.6 whole square is 12.96 and so on. I hope it is clear. So these is nothing but log f of x equivalent to 2 log x. These is nothing but 1 by f of x, f dash x equivalent to 1 by x change x. 1 by x change x. I hope it is clear, right? So these nothing but, so that is the reason change is nothing but 13 and 9, which is nothing but 4. So double the value, double the value. F dash x is nothing but 2x. I hope the idea it is clear, right? So what you can do is, I did it for x square. For better clarity, you do it for root x. You will understand it much more clearly. Log f of x is nothing but half log x. Now you will understand it clearly. 1 by f of x. F dash x is nothing but 1 by 2 into 1 by x change x. This is what I did. 13 and 9 change is nothing but 4. 2 into, so root 9 it is nothing but 3. So delta x divided by 2x. Delta x divided by 2x. That is what we got the answer. Suppose if the question is root of 103, it is ending with 3. So it is not a perfect square. It is just greater than root 100. So 10 plus 103, 100. Difference is 3. Double the value. So these is nothing but very, very close to 10 3 by 20. 10 3 by 20. I hope the idea it is clear. Again I am telling you why this 3 by 20 came into picture. These is nothing but f of x is root x. Log f of x is half log x. These is nothing but 1 by f of x. F dash x. It is nothing but 1 by 2 into 1 by x into change x. These nothing but this value, sir. 103 and 100 change is 3. 2 into double that value. I hope you are all very, very clear with this logic. Root 87. 8 plus 7 is 15. 15 digital sum is 6. Perfect square digital sum should be 147 or 9. It is not a perfect square. Root 81. It is nothing but 9. 9 plus 87, 81, 6. Double this value. These nothing but approximately 9 1 by 3. 93 whole square, it is nothing but 8649. So that is the reason it is 9 1 by 3. Check the digital sum of that number. If it is not 147 or 9, use the logic non-perfect square. If it is 147 or 9, use the logic how to find the square root of a perfect square. I hope the idea it is clear. Now concept 2. Concept 2. How to find the cube root of a, how to find the cube root of a, first one perfect cube, next one non-perfect cube. How to find the cube root of a perfect cube? I hope till now it is clear to you. How to find the cube root of a perfect cube? What is the concept? A cube root has digital sum 1 8 or 9. Just give me, just give me 1 minute, sir. I will switch off the phone so that it will not be a disturbance to each one of you. Right? Now see here. How to find the cube root of a perfect cube? How to check whether the number is a perfect cube or not? Digital sum should be 1 8 or 9. Cube the root of 1728. What is the digital sum? 8 plus 1 9, 7 plus 2 9. Digital sum is again 9. Now see here. How to find out? Keep a slash after 3 digits. It is ending with 8. 2 cube is 8. 1 lies between which two numbers? 1 cube 1 and 2 cube 8. Take the smallest number. Answer is nothing but 12. I hope the idea it is clear. Second one. Cube the root of 32768. Cube the root of 32768. Keep a slash after 3 digits. 8. 2 cube it is 8. Only one number you will get. Right? Remember this logic. A perfect square never ends with 2 3 7 or 8. Only these numbers on cubing I will get 873 are 2, which is the tens complement of the given number. 32. 3 cube 27 and 4 cube 64. Take the smallest value. Smallest, it is nothing but 32. There are no two choices that is possible for a perfect cube. Directly you will get these answer. Suppose third question. Cube the root of 13824. 13824. Keep a slash after 3 digits. It is ending with 4. 4 cube it is 4. 13. 2 cube is 8. 3 cube is 27. So answer is 24. Answer is 24. I hope the idea it is clear. Please check the digital sum of every number. 8 plus 1 9 9. Digital sum of a perfect cube should always be 1 8 or 9. 8 plus 1 9, it is 9. If it is a perfect cube, the digital sum should be 1 8 or 9. I hope it is clear. Next, if it is a non-perfect cube, if it is a non-perfect cube, suppose if it is cube the root of 13, f of x is x cube. So if y is x cube, x will become y power 1 by 3. Y power 1 by 3. Sorry, we are doing for a non-perfect cube, not a non-perfect square. Non-perfect cube. Cube the root of 13. It lies between. Now what we did? Root of 29. What is the nearest perfect square? 25 5. 5 plus 29 25 4. These is nothing but double that number. 2 into 5, it is 10. I hope it is clear. So f of x is x square. X square differentiation is f dash x is nothing but 2 into x. This is what we got, 2 into 5. Similarly, f of x is x cube. So if I do different f dash x, this is nothing but 3x square. No change. Cube the root of 13 is nearer to cube the root of 8. Answer is 2 plus. So 13 is greater than 8. 2 plus. 13 and 8. What is the difference? 5. Here it is 2x. Here it is 3x square. 3 into 2 square. I hope it is clear. So 2 plus 5 by 4 3s are 12. Answer is very very close to 2 5 by 12. 2 5 by 12. So 5 by 12 is nothing but, if I do it in 12 40, right? 12 fours are 48, 2 and everything. I hope the idea it is clear, right? It is coming closer to 2 5 by 12. It is coming closer to 2 5 by 12. Similarly, if the question is cube the root of 68. Cube the root of 68. What is the nearest cube root? Cube root of 64. 4 plus 68, 64. 4. This is nothing but 4. Do 3x square. So 4 plus 3 by 16 3s are 48. Answer is nothing but 4 3 by 48. Answer is nothing but 4 3 by 48. I hope the idea it is clear. Cube the root of 817. If you see the digital sum, 8 plus 1 9, 9 plus 7 16, it is 7. The digital sum of a perfect cube should be 1 8 or 9. So it is a non-perfect cube. These nearer to cube 9 cube is 729. Cube the root of 729, it is 9. So answer will be definitely 9 plus. What is the difference? 817 minus 729 divided by 3 into 9 square. 3 into 9 square. I hope the idea it is clear. 9 plus, it is 88 divided by 81 3s are 243. Answer is closer to 988 by 243. 988 by 243. That means let us see. Suppose if it is root of x, the nearest perfect square is root of y. The value is nothing but k. So what we did? K plus root x minus root y. divided by 2 into k. Is this what we did? Root 13 is there. Root 13 is nearer to which perfect square? Root 9, which is 3. Answer is 3 plus 13 and 9. Difference is 4, which is 2 into 3. This is what we did. Same logic. Cube the root of x. Nearest perfect square. Let me take cube the root of y, which is k. So answer is k plus cube the root of x minus cube the root of y. I took a perfect square just less than cube the root of x divided by, here it is 2k, here it is 3 into k square, here it is 3 into k square. So let us generalize it for any number. Nth root of x. So what is the nearest perfect square? Nearest perfect square. Let me take nth root of y. It is nothing but k. So k plus nth root of x minus nth root of y. If it is root x, so we got it as 2 into k. Here it is 2 into k, because y equivalent to k square 2k, y equivalent to k cube, which is 3k square, y equivalent to k power n into k power n minus 1. This is how you find the approximate value. This is how you find the approximate value of a non-nth root. This is how you find the approximate value of a non-nth root. I hope the logic is clear. If he asks approximate value of a fourth root, you can solve it. Approximate value of a fifth root, you can solve it. In perfect square, two logics are there. A perfect square digital sum is 1, 4, 7 or 9. If it is not 1, 4, 7 or 9, use a non-perfect square logic. How to perfect cube digital sum should be 1, 8 or 9. If it is not 1, 8 or 9, use the approximate value of a non-perfect cube. I hope the idea it is clear, right? So what, with all the concepts that we discussed, I will just write down the concept. Flowchart. Flowchart to solve simplification problems. If anybody understands these flowchart, then it becomes very easy for you to solve simplification problems. Flowchart to solve simplification problems. The first thing is, check if the unit digits are different. Check if the unit digits are different in the answers. If they are different, use unit digit logic. Use unit digit logic. Second one, check whether last two digits are different. When I do problem, you'll understand the flow chart clearly. Check whether the last two digits are different in the answer options. If they are different, use last two digits logic. Use last two digits logic. Point number 3, check whether digital sum are different. Check whether digital sums are different in answer options. If they are different, use digital sum. If none of these is working, if none of the digital sum of more than one answer option is same, last two digits is same, and unit digit is also same, then use the concept of speed calculations. Speed calculations. However, what you can do is, you can also use divisibility rules. You can also use divisibility rules to eliminate few answer options. Few important things which a student should keep it in mind. Before solving simplification problems, he should know how to use a number tree. Even plus even, it is even. Even into odd, any number multiplied by even, it is even. Odd into odd, odd into odd, it is nothing but odd. It is nothing but odd. Odd plus odd, It is nothing but even. Now you will understand how am I using these basics foundations of number tree to solve most complicated problems. Before you solve a simplification problems, first have a look at the answer options. If unit digits are different, use these logic. If the digital sums are different, use these logic. If first three are not working, use speed calculations logic. Also use the concept of divisibility rules and number tree to eliminate incorrect answer options before you proceed for 1, 2 and 3. Listen carefully. One by one we will discuss. See this problem. Square root of 1156 plus cube root of 215952. First, before you solve the problem, do these acid test. 1156, it is an even number. Square root of an even number, it is an even number. 21952, it is an even number. Cube root of even number, it is an even number. Even number plus even number, answer should be an even number. Before itself solving, 63 and 67 both are out. 63 and 67 both are out. Unit digits of option A, C and D both are different. I hope you have understood why B and E are eliminated. This is the first acid test. Second one, root of 1156 plus cube the root of 21952. 6 plus 5, 11, 11 plus 2, 13. 13 digital sum is 4. Right? 7, 7 plus 2, 9, 9 plus 9, 18, which is 9. So, if it is not 1, 4, 7 or 9, then it is you have to use the concept of approximate value of a non-perfect square. It is ending with 6. So, the unit digit will be, if it is ending with 6, either 4 or 6. Anyway, it is cubed root ending with 2. So the unit digit will be 8. We already discussed what is that a perfect square never ends with 2, 3, 7 or 8. Only 2, 3, 7 or 8. On cube I am getting the answer 8, 7, 3 or 2. I hope it is clear. Now see here. 4 plus 8, it is 12, 2. 6 plus 8, it is 14, 4. Answer unit digit should be 2 or 4. So 56 it is eliminated. 56 it is eliminated. Now see here. Suppose if I keep a slash after 2 digits. 3 square is 9, 4 square is 16. Answer is 34 or 36. If I keep a slash after 3 digits, 2 cube is 8, 3 cube is 27. This is 28. So, if I do digital sum concept which we discussed, square root of 1156 is 34. 1156 will be equivalent to 34 whole square. Digital sum is matching. This is not possible. 34 plus 28. What will be the answer? 62. What will be the answer? 62. All the concepts we discussed, even plus even, it is an even number. Answer cannot be 63 and 67. It is out. 1156, it is ending with 6. So if it is a perfect square ending with 6, unit digit will be 4 or 6. 4 or 6. 3 square 9, 4 square 16. So it will be 34 or 36. It will be 28. Answer will be either 34 or 36. Anyway, if you see here, 36 is divisible by 3. 1156 is not divisible by 3. I hope it is clear. Suppose root of 9 equivalent to 3. Root of 2025 equivalent to 45. 45 it is divisible by 3. 2025 is also divisible by 3. 36 is divisible by 3. 1156, what is the divisibility rule of 3? Sum of the digits should be divisible by 3. 11 plus 1, 12, 12 plus 1, 13. 13 is not divisible by 3. These out. So 34 plus 28, 60. You can skip this step of finding the digital sum also. I hope the idea it is clear. First one, I hope the idea it is clear. Second one, 24, 36, 14, 83, 15, 67, 34, 28. Keep an eye on the answer options. All the unit digits are different. So play with unit digit. 6 plus 3 plus 7 plus 8. 6 plus 3, 9. 7 plus 8, 15. 9 plus 5, 14. Unit digit it is 4. Only one option it is 4. These by using unit digit. 2436 even number, 1483 odd number, 1567 odd number, 3428 even number, even plus odd it is an odd number, odd plus even it is an odd number, odd plus odd answer should be an even number. Odd number, odd number, odd number. It is not possible. Are you all with me, sir? I hope the idea it is clear. This is method number 2. Method number 2 it is based on number tree. Method number 1 it is based on unit digit. It is based on unit digit. You can also use divisibility rules to get the answer. Divisibility rules. Divisibility rule of 4, right? Because here we took the divisibility rule of 2. There we can take the divisibility rule of 4. Only the concentration is on last two digits. 36 divisible by 4, 28 divisible by 4, 4 20s are 80, reminder it is 3, 4 16s are 64, reminder it is 3, 3 plus 3, 6, 6 when divided by 4, answer should be when divided by 4, it gives a reminder 2, answer when divided by 4, it gives a reminder 2, 23, it gives a reminder 3, 45 it gives a reminder 1, 57 it gives a reminder 1, 14 4 3s are 12, reminder 2. Either you can use divisibility rule of 4. This is the beauty of simplification problems if you know the concept. Divisibility rule of 4. Divisibility rule of 4 you can use, unit digit logic you can use, and number tree logic you can use. This is where I will give you multiple ideas on how to use the concepts which I discussed, multiple ways of solving, understanding which way it is better. Here the unit digit it is different for all answer options. So you can use unit digit logic so that you will get the answer fast. If there is an answer option, if there is an answer option with more than one unit digit, you can probably use the another options. Now see here, 250 into 25 percentage, 350 into 55 percentage. So these is nothing but 250 into 25 plus 350 into 65. Percentage means into 100. All these dots are out. All these dots are out. Now see here, what is that concept that we discussed? A5 into B5. When you are multiplying two natural numbers ending with B, if A and B both are even, last two digits will be 25. When A and B both are odd, last two digits will be 25. One is even, another is odd. One is even, another is odd. The last two digits will be 75. Number before is given by the logic A into B plus A plus B by 2. Here if you get any decimals, please ignore the decimals. First method we will see, then another method also we will see. Ignore the decimals. A5 into B5 is A into B plus B by 2. If you got 3.7, it is 3. You got 3.1, it is also 3. First, make a note of this important concept. When you are multiplying any two numbers ending with 5, A5 into B5 is A into B plus A plus B by 2. Last two digits will be either 25 or 75. First we will see the concept with some application so that if the problem changes, still you can use the concept when it is ending with 5. A5 into B5. These is nothing but A into B plus A plus B by 2 ending with 25 or 75. When it will be 25? When both A and B are even or A and B are odd. When A is even, B is odd. When A is odd, B is even. Last two digits is 75. Here ignore the decimals. Here please ignore the decimals. Now let us see the idea. 45 into 65, a5 into b5, these is nothing but 25. 4 6 are 24, a plus b, 4 plus 6 10, 10 by 2 it is 5. So answer is 2925. Suppose if it is 35 into 85, 3 is an odd number, 8 is an even number. These are nothing but 75. 3 8s are 24. 8 plus 3 11. 11 by 2 5.5. Ignore decimal. Answer is nothing but 2975. Answer is nothing but 2975. I hope it is clear. All are ending with 5. So I want to introduce a new shortcut to you so that you will come to know how to solve this problem. Now if you see here, this is the traditional method. This is how most of the students solve it. Then I will discuss the optimal method. This is nothing but 250 into 25 plus 350 into 6.5. So these are nothing but 250 into 25. 250 into 25. 10 and by 10 it will be cancelled. These are nothing but 350 into 6, 35 into 65. All the dots are eliminated by 100 means it will become 8425, 8055, 8515 and 8525. So these are nothing but 6250. 35 into 65. Just now we discussed. Odd 5 into even 5. Last two digits is 75. Last two digits it is 75. 6 3s are 18. 9 by 2 4.5. This is 20 to 75. This is 20 to 75. So answer last two digits will be 75 plus 50 25. So here there is 25, here there is 25. 62 plus 1 carried. These is nothing but 85 25. So answer is option number D, 85.25. If just to tell you the concept of how to multiply A5 into B5, we have seen this concept. But this is a very relatively easy question if you know the concept of digital sum. Method number 2. Method number 2, digital sum. Let us apply digital sum. These is nothing but 250 into 25 by 100 plus 350 into 6.5 divided by 100. 100 digital sum is 1. Apply the digital sum for every question. 250 it is 7. These also 7 plus 350 digital sum is 8. Digital sum will not change with because of decimals. 6 plus 5 it is 11. 11 is nothing but 2. So divided by 1. 7 7s are 49. 8 2s are 16. 49 plus 16 65. 65 digital sum is nothing but 2. 65 digital sum is nothing but 2. 8 plus 4 12, 14 19, it is 1. These 9. These 5 plus 5 10, it is 1. If you see here, 8 plus 5 13, 13 plus 2 15, 15 plus 5 20, 20 digital sum is 2. Already we discussed. What is that we discussed? If the fractions are there in the simplification session number 1 we discussed, if it is numerator by denominator, denominator can be 1, denominator can be 2, can be 5, can be 4, can be 7, can be 8. If it is 2, multiply by 5. If it is 5, multiply by 2. If it is 4 7, if it is 7 4, if it is 8 into 8. When the denominator digital sum is 3 6 or 9, then it becomes a recurring decimal. Method number 1, 1. Concept of how to multiply numbers ending with 5 we discussed. How to use a digital sum also we discussed. Next one, 383. Now see here, 383 divided by 25 into 2.5 plus 12 into 2.5 plus 12. Now, if you see 25, what is the digital sum? 7. If it is 7, already we discussed, we have to multiply by 383 into 2.5 into 4 divided by 25 into 4 plus 12. If the denominator digital sum is 7, multiply it with 4 so that the denominator digital sum will become 1. So these 1, 4 into 383. 3 plus 8, 11. 11 plus 3, 14. 14, it is nothing but 5. 2.5. 2 plus 5, it is nothing but 7. Plus 12, it is nothing but 3. 4 5s are 20, it is 2. 2 7s are 14. 14, it is nothing but 5. 5 plus 3. 5 plus 3, answer digital sum is 8. 5 plus 3, answer digital sum is 8. Now, if you see here, listen carefully, sir. 5 plus 3. First one, it is coming to be 8. Next one, 2, 4, 6, 7. 7 plus 4, 11. It is not coming. These 1, it is not coming. 5 plus 4, 3 plus 2 plus 1, it is not coming. So answer is 50.30. Answer is 50.30. I hope the idea it is clear, right? I hope the idea it is clear. Clear, right? Or probably these method number 1. These method number 1. Now listen carefully. Method number 2. Method number 2. These nothing but 383 divided by 25 into 2.5 plus 12 into 2.5 plus 12. Now see here. Listen carefully. These nothing but 2.5 tens are 25. These nothing but 38.3 plus 12. Answer is directly 50.30. Very, very easy question. 2.5 tens are 25. 383 divided by 10 is 38.3 plus 12 is 50.30. This is much easier compared to that one. Only thing what you need to know is the concept of BODMAS rule, where division should be performed first before multiplication. Division should be performed. Don't do 25 into 2.5 first. Do 383 divided by 25 first. I hope the idea it is clear. Next one. 29 percentage of 265, 23 percentage of 435. Unit digit is same for all the questions. Last two digits is same for 6. Then use the concept of digital sum. 29 into 265 plus 23 into 435 divided by 100. 100 anyway, digital sum it is 1. 29, digital sum is 2. 2 plus 6, 8. 8 plus 5, 13. 13, it is 4. Plus 23, digital sum is 5. 4 plus 3, 7. 7 plus 5, 12. 12, digital sum is 3. 2 4s are 8. 5 3s are 15. 8 plus 15 is 23. Answer digital sum should be 5. Answer digital sum should be 5. 9 out. 6 plus 5, 11. 11 plus 1, 12. 12, it is 3. 9 out. 7 plus 7, 14. 14, it is nothing but 14, it is nothing but 1 plus 4, 5. I hope it is clear how to use digital sum in a percentage problems. These concepts are extremely important even in DI problems, where you will get percentage increase and decrease. Weighted average problems also, this will be of extremely useful. I hope you are all enjoying the class. 40 percentage, these nothing but 40 into 60 into 3 into 2750 divided by 5 into 100 into 100. 100 digital sum is 1. Here also it is 1. If it is 5, multiply and divide by 2 to apply the digital sum. So here the denominator digital sum will be 1. These nothing but 3 2s are 6. 6 6 are 36. 9. 9 into any number. Answer digital sum should be 9. Answer digital sum should be 9. These not 9, these not 9, these not 9, these not 9. Answer is just nothing but 396. Most powerful concepts of Anil Nair, where you can solve most of the problems faster than a calculator or without using pen. I hope you understood the logic. Please watch simplification session 1 to understand the concepts again. These nothing but 8.4 into 6.5 plus 4.6 into 11.5. These is nothing but x divided by 4. So x is nothing but 4 into 8.4 into 6.5. Unit digit is same for all the above. Plus 4.6 into 11.5. First apply the concept of digital sum. If I apply the concept of digital sum, x equivalent to 4 into 8 plus 4, 12, 12 it is 3, 6 plus 5, 11, 11 it is 2, 4 plus 6, 10, 1 plus 1 plus 5, it is nothing but 7. So 4 into 3 2s are 6 plus 7. These 13 4s are 52. 52. 52. 5 plus 2. What will be the answer? 7. Answer digital sum should be 7. Answer digital sum should be 7. I hope the idea it is clear. Answer digital sum should be 7. These one way to do it. I hope the idea it is clear. All the last two digits of the answer is little different. So what we'll do is, let us check by using answer options what will be the things. Now these nothing but 84 into 65 divided by 100, keep it aside. 46 into 115 divided by 100, these nothing but x divided by 4. These is nothing but x divided by 4. Now what you can do is 84 into 65. How to find out the last two digits? Already we discussed. 84 divided by 100 minus 16 into 65. These nothing but 65 divided by 100 minus 35 plus 16 5s are 80. 48 plus 8, 560. So the last two digits of this number, it is nothing but 60. Next it is 46 into 115. 46 into 115 divided by 100, 15. 15 6 are 90. 60 plus 9, 69. So these nothing but 60. These last two digits it is nothing but 90. 60 and 90 divided by 60. These are the last two digits of 60. These a and it is b divided by 100. These nothing but x by 4. These nothing but x by 4. Now if you see here, so dot will be there. 60 plus 90, 150. 150 means 0.5 will be there. So depending upon the, what you do is, suppose if it is 430. 430 divided by 4. 4 11s are, 4 10s are 40. 107.5. This should be 107.5. Let us see what will be the 84 into 65. 84 into 65 can be written as 84 into 5 into 13. I hope it is clear. These 420 into 13. These easy to compute. So 13, these nothing but 13 20s are 60. That is what the last two digits we got it. Next one, 46 into 115. We are just checking whether the last two digits are same. 5 into 23. These are nothing but 230. 230 into 29. These 5290. These 5290. Now if you see here, these 5290 and it is some 5400. So approximately the answer will be 107.5. I hope the idea it is clear. Right, a value we got, b value we got, we substitute it, we got the answer. We substituted it, we got the answer. Now 1 minute, let me see if there are any better methods to this problem. Better methods to this problem. 1 minute. This is right. Now if you see here, hmm, if you see here 8.5 into 6.5, but all the options tens place we require, right? Tens place is, if I divide by 100 I will get it. These is nothing but 60, these is nothing but a, these a and it is b, divided by 100 equivalent to x divided by 4. So probably the best method to solve the problem, it is nothing but the digital sum. It is nothing but digital sum is the best method. All the answer options digital sums are different. Now the next question is x divided by 405.5 plus 183.75 equivalent to 63 divided by 3 by 4. So into 4 by 3. These nothing but 9, 5. 5 means numerator and denominator I should multiply by 2. Digital sum. I hope it is clear. Plus 8 plus 1 cancel. 7 plus 3 10. 10 plus 5 15. 15 is 6. 3 2 tens are. These are nothing but 2 10 digital sum is 3. 3 fours are 12. 1 plus 2 it is 3. So 2x plus 6 equivalent to 3. So 2x equivalent to minus 3. If the negative remainder comes in digital sum, add it with 9. 9 minus 3, it is nothing but 6. So x is nothing but 3. X value, question mark value, answer it should be digital sum 3. Let us see. These are nothing but 5. These are nothing but 1. These are nothing but 10 plus 2, 12. 12 it is nothing but 3. These 7 plus 2, 13. 13 it is nothing but 4. These nothing but 8 plus 5. 13. 13 plus 2, 15. 15 it is 6. So we got the answer by using digital sum. In digital sum, if the denominator it is 5, multiply by 2. In digital sum, if you get the negative remainder as minus 3, add it with 9. Digital sum is also the remainder when you divide a number by 9. Next one. 29 percentage of 265 and plus 23 percentage of 235. Denominator all it will be by 100. By 100 digital sum is 1. So apply the digital sum in numerators. Apply the digital sum in numerator. 29 it is 2. 6 plus 2 8. 8 plus 5 13 which is 4. 23 5. 5 plus 3 8. 8 plus 4 12. 12 it is nothing but 3. These one value minus 242. 8 8s are 64. It is one value. These 9 over 6 plus 5 11. 11 digital sum is 2. 2 ones are 2. 2 value. 2 fours are 8. 8 plus 15 23. 23 minus 1 plus 2. 25 minus 1 24. Answer digital sum should be 6. Answer digital sum should be 6. It is 1. It is nothing but 6 plus 1 7 9. These nothing but 6 plus 1 7 9. These 9. 6 plus 2 it is nothing but 8. These nothing but 2. So which option it is 9? Let us see. Which option? 29 digital sum is 2. 265. 8 plus 5 13 it is 4. 23 5. 8 plus 4 12 it is nothing but 3. 8 into 8 8s are 64 it is 1. So just go little slowly sir. 6 plus 5 11. 11 is 2. 2 into 1. 2 fours are 8. 8 plus 15 23. 23 minus 1 22 plus 2 24. 24. Answer digital sum should be 6. So 9 is out. 3 plus 5 out. It cannot be. 9 is out, 8 plus 1 it is out, it cannot be, it cannot be. 9 is out, 8 plus 1 it is out, 6 plus 1 7. So 1 you are getting, 4 plus 2 6, 6 plus 2 8. Let us check the digitals, unit digit. 9 5s are 45, 3 5s are 15, again 5, 8 2s are 16, 6.5 percentage, that means 6.5 divided by 100 into 190. These out, these out. 6.5 into 6.5 into 1.9, 6.5 into 1.9. So I will get here also 29. These 9 5s are 45, there is no decimal. 3 5s are 15, 8 2s are 16, 8 2s are 16. All the last two digits is also same. Somewhere the digital sum calculation, let us check it again. 29 digital sum is 2, 265, 2 plus 6 8, 8 plus 5 13, 13 it is 4, 2 into 4 over 23 it is 5, 435, 4 plus 3 7, 7 plus 5 12, 12 it is nothing but 3. This first step it is right. Minus 8 into 242 it is nothing but 8, plus 6.5, 6 plus 5 11 which is 2, 190 it is 1. So 2 4s are 8, 3 5s are 15, 15 it is nothing but 6, minus 8 8s are 64, 1 plus 2 1s are 2, 8 plus 6 is 14, 5, 5 minus 1 plus 2, 7 minus 1 6. Answer digital sum should be definitely 6. If any of the answer options are matching, then that is the answer. If it is not matching, then the answer is not. I hope the idea it is clear. If any calculation mistakes are there, please take care of it. Now all the answer option last two digits are different. So let us go. 68 plus 58 minus 96 minus 21 minus 62 equivalent to x. I kept everything onto the left hand side. I hope it is clear. 68 plus 58 16, 11 it is nothing but 126, 26 minus into minus 4, these minus 83 equivalent to x. So these nothing but 26 plus 4, 83 divided by 100 minus 17. So these nothing but equivalent to x. 30 plus 17 x. Last two digits should be 47. X last two digits should be 47. Last two digits should be 47. These are not possible, not possible. So let us see if the digital sum is also matching for 1247. If it is not matching, then the answer is none of this. 6 plus 3 out, 4 plus 8 12, 1 plus 2 3, 8 plus 1 out it is 7, minus 9 out, 6 plus 5 11, 11 it is 2, minus x equivalent to 1 plus it is nothing but 2, 10 minus 2 8, 8 minus x equivalent to 3, x is nothing but 5. Answer digital sum should be 5. Answer digital sum should be 5. 7 plus 2 9, 4 plus 1 it is also 5. I hope you have understood all the problems. Just keep an eye on the answer option. There are more than one answer option with the same unit digit. So I went with the last two digits. Last two digits for four options are different. So first I did the last two digits. I did not even calculated for more numerical values. These 26. 96 divided by 100 minus 4, minus 21 minus 62 is minus 83, minus 83 negative reminder, positive reminder 17. Don't make your life complicated. I hope this problem is also clear. Digital sum should be 6. This problem is also clear. If the denominator digital sum is 5, multiply it with to numerator and denominator. This is a generic calculation, use the digital sum, right? This is nothing but denominator 5 multiply the numerator and denominator. Again it is nothing but digital sum concept in percentages. When to use digital sum, when not to use digital sum, it is clear. BOD-MAS application, digital sum application, A5 into B5. Three methods of solving the addition related problems, right? Even plus even is even number or using the unit digit. I hope you understood the speed calculation simplification session number 2. We will do a lot more session. In case if you are enjoying Anil Nair's way of solving after you have watched, don't forget to click on the like button and give any comment in case if you got any of the academic doubt. If you think that I teach differently, kindly share this video in every social media wherever you are present. In case if you are looking for any of these courses where all the quant classes are taken by me, placement CRT course or bank course or SSC course or the hottest selling CAT course, feel free to WhatsApp me to know further more details. 80500 So here there are close to 700 plus hours of content is there. Here 450 plus hours of video content is there along with the test and PDF. Here there are 350 plus hours of content. Here it is 300 and here it is 400 plus hours. Here it is 350 plus hours of content. Thanks a lot for watching the video. Don't forget to click on the share button and share it with all your friends. Thanks a lot. With love, Anil Nair.